Your audio's quite low, Gary.
Is my audio quite low? Hang on,
It's
I'll
lower
go up
than.
here to make it any higher.
Yeah, that's better. You stand higher.
Yeah, that's right. Good afternoon, good morning, good evening, wherever you might be in the world. Just three of us here, man. And as Rev is saying, how the heck is it Tuesday again? That's true. We have been 30 hours without power now, and absolutely nobody has come to fix the problem. I've seen the problem. The tree fell over the lines last night or yesterday, 30 hours ago. And yeah, that's been that. As well as having 10-hour load sheddings anyway. We're getting oh, Mr. Rouse is here. Wednesday or yeah, Wednesday already for Philip and Bruce. Of course it is, yes. That's very true. We are very, very honoured to have Colonel Steve Luxion. Luxion, is that right, sir? Or Lux, as you like to be known, from Assure, Centre of Excellence in America. And they are the people that are doing the science that really counts in our world and the science and evidence gathering that we need, not to make a case against aviation authorities, but I suppose I want to say to hold some truth to them. You might have some better words. What words would you use, Bruce? What is this science doing?
You just to introduce some science for a start instead of hysteria and speculation.
Yeah, yeah, that's true. So straight away, before I go any further, I've already got a couple of questions from people on the world of LinkedIn. So Elliot Cork has asked Steve, do you have you done all your images seem to sort of have phantoms and things like that in it that we've seen so far? Do you have a database of different types that you've chucked at dummies and all the other things you've done? And if so, how's that helping you?
Yeah, so we have done various studies with different bodies, different equipment as we move forward. We started with the DJI Phantom 3, and that platform is kept pretty much standard, although we're starting to run out of them through all our studies. So there's a common thread through all of them, so we can look at the differences on different studies that, are they matching up, not matching up? Does it make sense? It helps to validate the modeling when we do the modeling. We also do a bunch of testing to validate modeling independently. We've done on our human air to ground studies, we've done what we call human matching studies with cadavers, not just the test dummies, and running running with UAS, working, what is the damage to an actual human. And what we try to do is be actually still very, very conservative, although when you see our results, you can see that a lot of the hype is hyperbole and it's not necessarily proved out in evidence. But we do it so that all the assumptions tend to line up to, the most critical case. And even when we did the human matching studies, we didn't even get to the level of safety that in the United States, the Federal Aviation Administration was even concerned about. We had one level of one kind of issue, one injury that was minor compared to what we were trying to actually achieve.
Just to explain that again to me, explain it so the for dummies version, which is for me. So there you said there was an hello there, Ian, who is mad, as you've seen there, Lux. There's an industry. The FAA was expecting injuries of a certain type, and right. You weren't able to get there.
Yeah. So first of all, when I'm talking about our research, I'm the guy on the commercials in the United States. I stayed at a Holiday Inn Express, and I kind of work. I get to work with all these phenomenal PhDs. I'm kind of the manager of the European football team that tries to get all these premier players to play well together and put the right team on the field and mentor and coach them. But they're the absolute experts. So on this air to ground studies, yeah, all the knowledge has come out of came out of a bunch of studies that were done in the U.S. on Department of Defense test ranges for explosives and spacecraft, very heavy metals designed to penetrate, tanks and people. So they used that, and they used it with pigs and various other mechanisms as proxies for human beings. And probably overall, it has been the body knowledge for 60 years, maybe. So it's become accepted as that is the answer. But if you look at UAS, they are not made with heavy metals, and even most aircraft are not made with heavy metals. Now we have composites and the thermoplastics that flex and bend. And when we went through the initial testing, the very first phase, when we just tested the systems against crash test dummies, a few in the FAA said, surely this is wrong. You need to go back and redo it. So our lead researcher, a guy who served as a test pilot for the Army in helicopters, he came in with a titanium pipe and steel that was used in the original testing, had people kind of just softly tap their heads with that, and compare it to tapping a drone of similar weight in plastic. And you could feel the difference. And so we had to go back and rerun all these tests again, showing the flex and how these things spring off of the head, and most of the energy is retained in the aircraft. It doesn't actually transfer to the human being. Transferred energy to the human is actually then results in injury, or in aircraft, when we hit aircraft, it results in damage to the aircraft. And we are finding significantly, like order of magnitude less or two of damage was being caused. And that's why some in the FAA and some still today across the world just don't believe those studies. But we then did matching studies against humans, and we validated our work. I got to participate in one autopsy of the injured cadaver, and it was very, very interesting. But yeah, I'm a lacrosse player. I'm a lacrosse referee. I could get hit with the ball and get the same kind of damage to my a hairline fracture to my bone just above the eye into the skull.
I wish I had a hairline. Never mind. So this pushback, do you think are you overcoming the pushback, or is there still this resistance to anything that doesn't fit the current narrative, regardless of how scientifically conducted the tests are?
So a couple of very interesting points, and hopefully we'll get to them. So first of all, Assure had to establish itself, right? We're now in our 8th year. I work with amazing researchers across the globe now. We have international affiliates, including Cranfield there and Southampton in the UK. But it took some time to establish our credibility and actually do research that was impacting on regulation and standards. You know, everybody's trying to find their way. How do you employ us? How do you use us? And how do we serve best? So these studies were some of the initial studies coming out of Assure. Some studies were better than others. This one was really good, going the right way. But we might have had some other studies that weren't actually answering the right kind of questions and didn't look as good. So we as Assure, as the research body, had to build up our credibility in our database. So the FAA or anybody dealing with this, how do you trust something that you don't know yet? And it's developed. So I would say today it has really improved quite a bit. Our research is now very well respected, published, and used throughout the world. I've worked with a lot of different civil aviation authorities. So that part is changing. The anecdotal answers are not sufficient anymore. When we are commissioned to do work, we do that work, and we do it on a very unbiased basis to kind of work through the issues, both pro and con, of what we actually find. I'll bring up one other point, though, that what you may be seeing is these autonomous vehicles, robotics, everything, tend to bring on, especially in the airspace, if you put more things in the airspace, the aviation authorities anecdotally generally are saying, well, this is more dangerous, right? I have more things moving around. How do I manage control? But what they don't address is the amount of reduced risk in other things, like climbing towers or getting a drone that has medical supplies to somebody quickly. and actually saving their life, not the possibility of running into somebody and falling out of the sky with the perfect shot in the head that might injure them, not even kill them. So that transferal of risk is, whose responsibility is that? Is it the Civil Aviation Authority of the UK and the FAA in the United States to worry about all that? They're worried about airspace and a little bit about commerce. So what's happened, I've seen a turn in the last year. I met with the Ministry of Business and Innovation in the UK, and they took some of the work we were doing and were asking us some of these kind of questions where it's benefit here. Have we done any work to show the overall systemic benefit against any kind of risk that we may impose on the airspace? And we started doing some of that work. It didn't get completed because the FAA was concerned about us using real dollars against somebody's life and what that is in insurance. I think it was probably a little bit more that they weren't necessarily liking the answers, because it's order of magnitude benefits that we were showing, at least in some of the applications, if not most.
I'm gonna have to have the for dummies bit again. Order against life. I don't understand that bit. Spending dollars against life.
Yeah. So one of the things the FAA says is we're concerned that, the possibility that a drone may hit somebody and kill them. So we know what the odds or the chance of that actually happening, 10 to the minus 13 times. So I put that against my life. Well, there's insurance numbers out there, but let's say my life is worth, as far as insurance is concerned, $2 million. That's on the negative side, the risk side. On the positive side, I need a kidney, and that kidney's being rushed to the hospital as I lie there, ready to expire, and it saves my life. So then it's a 1-to-1 mix at the percentages that these things can actually pull off. So we've done a little bit of that work. We're trying to, what we did get to complete was a thing called de minimis risk. What is the equivalent risk for trying to do some type of operation in transportation or inspections? If it's, the risk to the human is 10 to the minus 3, there's 1 in 1,000 chance the individual will get hurt in civilian life climbing a tower. But in the drone business, it's 10 to the minus 9, whatever that number, 1 to the billionth, or trillionth chance of getting injured. We were able to go, okay, we're wasting a lot of time on tower inspection drones because we don't need 10 to the minus trillion. We just need to get it better than what we do for the guy climbing up and down the tower, as long as we're not transferring the risk to anybody else. As they look at that.
You need to unmute, Bruce.
Sorry, yeah. Dayton University did some trials, and there's also been other trials commissioned by the media which have been very less than perfectly scientific or unbiased, in my opinion. How does that impact the work you're doing when they seem to produce different results, perhaps? And how do you counter that sort of perception that, these things are so dangerous because we saw one plow into the leading edge of a light aircraft tailplane or something like that?
Right. So what we do, we follow very good practice, just like any other business profession, medical profession, football player, whatever. We start at the very basics. What are the studies that have been out there? So our researchers, and we lay out a full test plan of when we do proposed work, how this will all kind of play out. So, we'll go do all the literature review, all the studies that exist, look at those studies, find out what they've done, and not repeat necessarily anything. But if there's issues, it hasn't been peer reviewed, where are the potential problems? And then we move it forward in discussion with the regulator or the sponsor. Here's what we think we should do. Now, they're obviously the one that needs the work done, so we're open to that. And we also bring industry in. Industry saying, wait a minute, FAA, you're not letting me do this because you fear X. So we'll try to help industry out and work that X problem and get that solved. So all of that is laid out in a game plan before we ever start that research. knowing what is it. We brief out all those studies that really are pertinent, and then how we're going to move all this science forward. And that's part of academic life I had to get used to. I'm a retired colonel in the Air Force. I wasn't used to people challenge me on every single freaking issue when I said, go do something. They did it. But in academia, it is constant criticism and critical review and look. And I have found over time, what used to frustrate me is really the strength of our research when we bring in the NASA's, we bring in other countries' experts when we do our peer review. And then actually, as we conduct research, they are typically welcomed in during the technical interchange meetings at a lower level of the great detail of how that research is being done, so that we get, hopefully in the end, a better result. And that challenging, that counter study loses its merit just through the academic process.
Now, this stuff must cost a lot of money. Obviously, doing this kind of research isn't cheap. Now, and as you mentioned, sponsors. So you have organizations, industry groups come to you and present you with a test they want done, and they pay the costs. Do you do any self-funded tests purely from an academic perspective?
I would say, well, when we do our work as the Center of Excellence, one of the rules that Congress has imposed on us is the one-to-one match. So we're already in our research, 50-50. We get $1 million, we got to come up with $1 million on our own of in kind. Now that's in kind. So usually we're not writing a check for dollars, but we are taking a student and we're bringing them and paying that student who's a PhD doctorate, who's trying to gain expertise in this area, many areas that no one has any expertise on. So they will be the residual, when the project's done, expert in this area. So we get this person trained. The schools are paying for that individual to be trained, and their time and effort and equipment that it's associated with. So de facto, for our Center of Excellence work, it's one-to-one. When we work with industry, it's industry or other governments. We don't necessarily have to match one-to-one, but a lot of all that stuff is in place, and we use the knowledge we already have. And on the good news side of it is the Center of Excellence, all our research is publicly releasable. I have to fight at times to get all that information out, but it is publicly releasable, unless it's classified or we're protecting an industry secret. But we learned how to protect those kind of things and still get the safety issue clearly defined.
And so what sort of dollars are we talking about? Say someone came to you and said, we want you to test the risk associated with this falling from 30 feet onto someone's head. What sort of dollar figures would you roughly be looking at to do the testing and produce a report?
For what you just showed me is less than 250 milligrams. And I think we could just say, based on our experience, 0. Done.
Okay. What about as a choking hazard?
Yeah, now I have to find the experts on actually swallowing that thing, which is much higher. But yeah.
Are we talking small figures like 10,000, 15,000? Are we talking hundreds of thousands, millions, whatever?
Most of the work we do for the FAA is on the order of hundreds of thousands usually. The work we do for sometimes little things here and there, tens of thousands for kind of a quick look. But when you employ Assure, we are 28 international research institutions. We've got 130 industry and government partners we work with, and that whole infrastructure and bringing the right people together doesn't make sense to tackle necessarily that little $100, $10,000 job. Although we find that when we do find that work, we're happy to direct that right to that university or that expert to go do that work. If they need us to program manage it, we're happy to do that. But the most part, we'll just kind of hand that off to who we think and do the introductions and get the work done at the lower end.
Yeah, because what I'm thinking is that there's in order to push back, we've got a hobby where people are flying these things, and there's historical information suggests that it's incredibly low risk because of the type of craft we're using and the type of operations we're undertaking. But we have nothing we can prove, and regulators don't seem to be interested in looking at the historical data because, what if, and it's only a matter of time and whatever. We need some scientific data to back up our claims that this is very safe. And so I'm just looking at one of those options would be to commission a study, commission some testing on for stuff like that. And is it something that would fall within the practical realms of reality for us to fundraise that?
Yeah, so I think a lot of for example, if I was you, the first thing I would do is point us to the Assure website, find that research study, print it out, go through the executive summary, print it out, show that available and say, okay, what more do you need? And most of our studies also have accompanying all the data. So they can look through, and now it's on them to prove this data. There's something wrong with the data kind of going forth. Let's say there's a new piece of equipment, a new thing that you're trying to test. All the mechanisms, one of the nice things about Assure for the studies we've already accomplished, we try to eventually model. We have the most premier modeling institution, I think, in the world. It's called NIAR out of Wichita State University. They do everything for Airbus and Boeing and the defense contractors. So, and it's a university, and they're really good. We try to create models as much as we can so that if something new comes in, all we have to do is, and especially if it comes in with all the tech data, design information, the materials it's made out of, all that kind of stuff, then we don't have to reverse engineer it. And it becomes very, very simple for us to add it to the model, run bazillions of runs on all the different failure modes, and provide an answer pretty quickly, pretty easily.
Philip wants to do that. Is that sort of thing possible? Fly drones into static jet engines?
Yeah. So we are at, two things on this. We have developed, working with all the large engine manufacturers, 5 of them, Pratt Whitney, Rolls-Royce, I'll probably forget one, Honeywell, GE, of course I forgot whatever the 5th one is. We're working with them to create a generic model that's not purely any one of theirs, right? Because of sensitivity to their product. But we've created a model that with NASA that is going to be kind of the standing model that you could run any type of other UAS model into that system. Now, this is pretty high speed computing type stuff. The model just depending on what it's actually doing, sometimes takes 2 or 3 weeks to run as the computer crunches through all the data.
Wow.
But that model does exist and everything's going on. The follow-on work to that model is we're taking a real engine, and it's out at China Lake right now. It's up. The gun that's going to shoot the UAS into it, equated to takeoff speed, is there. Everything's gone. We run through all the preparation for this. We're running the engine, doing a bunch of testing on the engine, make sure it can get the full engine power, and all our cameras are right, all the digital camera, everything we can do possibly to scan all that equipment ahead of time, and then after, so we can learn from it. We will actually do that engine will be running at full power. We'll shoot the drone at takeoff speed to what we think is the worst case scenario. That airplane just airborne, a couple 100 feet off the ground, 100 feet off the ground, and taking a drone strike at the highest power setting that it can be at. Square in the engine, perfect shot, which is very difficult to do anyway in real life.
We've all tried it.
It's not easy. Yeah, even a terrorist trying to go for an engine or something is highly unlikely.
I suppose that's the other test, isn't it? Is just to have an engine size shape a distance away and see how many people can get it. But anyway, I digress. But you're right, that would actually be quite a hard task, wouldn't it?
Well, especially when you can, when it's moving, just all the flows we've done a bunch of work on our aircraft collision studies to look at the flow over the aircraft. What we found, when it's not a pure center of gravity on center of gravity hit, just a slight, like half an inch, quarter an inch off, causes it to tumble right off with maybe just a scratch on the leading edge of something.
The interesting thing with engine strikes is that, as we've seen recently, airliners can fly quite happily with an engine out. I mean, there was failed just on takeoff, didn't it? They returned and landed quite safely. It's not going to be, even if you have the probability that it will cause an engine failure as high, then the total risk still remains moderate because these craft are designed to fly with that kind of damage.
It's quite interesting, actually. Sorry, I'm going to say hello. There's the new world of shorts on YouTube and Facebook. Something I don't know if you guys have seen. There's a lot of aviation ones being posted now from air traffic control and planes having issues. And I've seen about 8 or 9 with an engine failure. And it is pretty much the most calming situation there is. The pilot just comes on. We've got an engine out. We're going to return. Everything's fine. Can you give us somewhere to go? It's like run of the mill stuff now. It really is. You know, don't get me wrong. If it goes bang and half of it's hanging off, that tends to be something different. But predominantly, it's not.
That's only Qantas does that.
Yeah.
The FAA says this all the time in our studies because the engine manufacturers were working. We're not looking to impose any additional restrictions on the manufacturers. We're hoping that they'll learn some things and maybe make some adjustments to the engines that they think they need to do. But the idea here is just what you said. The FAA says that's why we require 2 engines. So we're just making sure with this study that the research approach that Assure has taken, the modeling that the engine manufacturers and NASA working with Assure looks reasonable. What we've done is we've also modeled the real engine just to make using our techniques, and we'll see how it all goes. But what we get to do in this test is a couple things that we don't get to see every single day. But we got to remember it's a test of one, and it's like over $14 million. It might even be about 17 million. But as we put that UAV into the engine and we have all that information, one of the things that we don't model because it's just so difficult and it takes so much time to just run through this, like I said, just through the fan section can take weeks, but some will be bypassed around the edge. What does that look like? Some will be ingested into the core. What does that look like going through the turbine? And then ultimately, is the engine, all the failures and everything that we expect to happen, keep the engine on the wing, number one, that it doesn't just fall off. And 2, can the pilots successfully shut the aircraft down? Those kind of things we don't get to really explore in the fullest extent in the modeling. So this one test, unfortunately only one, not conclusive, will provide at least knowledge to pilots in the future what this might entail, how they may experience it, what's different than a bird strike as that happens.
It's interesting, isn't it? Because there are so many areas on the disc fan where impact would have a different effect. If you're towards the outer edge, then you're probably not going to get ingestion into the core. But if you're at the bottom, so how do you determine how you're going to set up your test? What factors do you use to determine? Well, we're going to aim at this point, or we're going to simulate this point, because that's going to have a huge variation. If it costs as much and takes as long as you say to run a simulation, that must be the most important thing is what you simulate.
A lot of time was spent on that because it's one test. So what they ended up looking at in the engine manufacturers themselves, the OEMs were very concerned about, was the amount of loss of material in that compressor section, because then the compressor fan is breaking down also. The drone kind of gets broken up really quick, but now we have metal pieces of the fan or composites of the fan moving around the engine. So if I remember correct, I think it's 80% of the span is where we're aiming for. And in lots of tests, that's where we have seen the most damage. We've done extremely high speed tests. So the worst case scenario is not the situation, at least of where our models show, where the airliner's at, let's take it above 10,000 feet. So it's going 300, 400 knots, and the drone goes right through. It goes through so quickly, that engine, that it doesn't affect a lot of blades. It's almost the slowest case that ends up affecting more of the fan blades as it goes through And out there on the edge is kind of where that damage is increased. Obviously, as you move into the nose, it pops itself against the nose. Now it's just going to kind of get, mangled up as it gets thrown around the engine and, out the back of that engine.
Yeah, I forgot what I was going to say now. Oh, I must be old. How does it happen? But they could probably extrapolate a lot of stuff because we've done all the tests with shooting chickens into fan discs and things. So if you know the level of damage, you can work out what that's likely to do in terms of whether it's going to pull the motor off the pylon and stuff like that, can't you?
Yes. So that was always the hope. So with our studies, we validate our model. That model we're working with the OEMs on using known things. That's ice. That's different size birds. The engine manufacturers know how that engine should perform from their experience. The other side of this thing is part of the deal when they came on to work with Assure, because this was scary for the engine manufacturers to actually participate with us, throwing crap at their engines, right? They want to know, but it's a potential PR problem, right? So what we did, again, NIAR, fantastic researchers, I said, okay, here's the deal. If you guys participate, we'll give you free our models, all the work that we have done to generate all these different UAS models, and you can run it against your own engine. And then when you come back in our technical interchange meetings and we're deciding, trying to get the model right, you can use what we hope you will do is you will use what you're seeing happening to your engines. That's all proprietary. They don't share any of that, to adjust our model to make our model better. And the engine OEMs have agreed to do that. They don't talk to Assure because they're so worried about all their secrets, but they do talk to the lead engine guy at the FAA, who's managing as the sponsor of our project, who then helps us get through all the issues and trade-offs in the modeling that we do.
So cool. Hello there, Phil. Phil's in Philip Rouse, who's he's got just the autopilot that you need to put on that machine as it goes through the engine, so you can log the data. Because I should imagine there'll be some weird accelerations for a few seconds, maybe.
If the SD card survives.
Yeah. No, thanks for joining us. It's so fascinating. And to me, it feels like so there's two sides of the coin here: the commercial drone operators and the model flyers that are represented by us, I suppose, as a group. But really, all of us have got to get behind and on board and be aware of this sort of research that's going on and be ready to use it, unfortunately, as a bit of a stick for the regulators. I don't want to say use it as a stick for the regulators, but say, well, as you said earlier, well, prove it. Here's the data. Well, prove it. Have you got some sort of chart that goes from 100 grams up to 100 kilos or something? Say it'll be this dangerous. Is there a single point where we can, or a single study where we can say it's like this? It weighs this much. It's like this.
So there hasn't been, but for good reason. Let me just comment on something. I'll get back to that. One of the things that our studies show, and what we need from groups like yours, the modelers too, is your equipment is dangerous. We don't want to be flying them around airplanes. We don't want to be taking pictures of approach. And when we see it, we freaking discipline our members that are doing this dumbass shit. Right? We keep it professional. We keep it safe. On your side of the question is, what does it look like? And we do have some variability studies that actually help define it against specific types of aircraft, because so much matters on the design of the aircraft. Let's take a pusher aircraft, actually a propeller right up front. It tends to then serve as like a needle poking a hole. Then you drive the engine through, and then the aligned battery through, and the camera all through, and it causes a lot more penetration and damage versus a quad or an octocopter that has all its stuff all spread out going into an engine or hitting something. It's nearly impossible. The center of gravity is actually probably nowhere near any of the main equipment because it's all dispersed and around. So that's one thing. But as things get larger, the answer is clear. 2 aircraft hitting in flight are never a good thing. When it's more of a bird size, then we want to be able to survive that strike. We do know that birds are typically about 90% fluid. So these UAS, even with all their thermoplastics and things like that, still have hard pieces in the cameras, in the motors, batteries. What does that all look like? And we've done a lot of research also on the batteries, the fire hazard and things like that associated with that. But yeah, there's no pure answer because as you look at the aircraft themselves, they're kind of built into different kind of categories. And once you start getting into the bigger ones, they are so big that they should be almost, and we're working something called a conspicuity study getting ready to kick off that will put all the lighting requirements on board these kind of actually various sizes. But when they start getting that big, we need to avoid it like a regular airplane. It needs to avoid it. And how do you see it? And so that we don't miss that this aircraft's out there and it get lost. It'll have flashers and then other things, ones that operate around people or over crowds. Maybe it has the backup, dump truck noise or some kind of noise as if it loses power that it's coming down. So people can take a quick look up and move out of the way, right? Because all
see what's going to kill them
is that pure strike on somebody's head.
Yes, some of that stuff you're mentioning there. I mean, the drone industry's been very proactive on. I mean, we've been supplying ADS-B in receivers with our autopilots as a standard thing now for quite a few years now. I mean, our autopilot is a few $100s. And it comes with ADS-B in, and it either alerts the pilot, or if you turn on auto avoid, it actually auto avoids a collision with an ADS-B aircraft because it knows it's there. Like the industry has actually been really proactive in so many areas like that. I mean, RPAS has a parachute mode that does put a buzzer off, whether if you trigger a parachute or things like that. But one thing we struggle to do is actually get any interaction with organizations like FAA, because we tend to be community organizations or smaller groups, and even though RPAS is the most used autopilot software in the world, because it's not one big commercial organization with lobbyists and this, that, and the other, it doesn't get into these things. It doesn't get into these meetings. We're not DJI. We don't have funding to throw at lobby organizations or jump on board FAA panels and this, that, and the other, because the money's not there to have people paid to do that.
But that's kind of our role, though. That's one of Assure's kind of mandates. Is we work with industry. You can participate in an Assure project. You become an Assure member, which is a no-cost kind of thing. But there is an expectation that then you are contributing to the research. You're running your system, your autopilot, whatever we're working on. And right now, we have at least 8, probably beyond visual line of sight, detect and avoid, rules of the road, rules of the way, right away, shielding, things all going on right now, tackling a lot of these issues. And we have companies, small and large, that are participating in that research to get the standard, get very clear of where industry is, that's where the technology is, and then where they're trying to go and where the regulatory stuff is blocking them. A lot of this is being worked into the standards groups, RTCA, so it's not even being managed by the civil aviation authorities. Assure has a testing group under the FAA that does verification validation of any standards. But the FAA has actually done one thing right. They've stepped out earlier working with these standards committees to bring in Assure research right up front. Instead of putting out a bad product or something that could be refined and made better, when you spend all your time trying to build consensus, let's get the data right, get the right way to kind of do it, and then work around consensus and the little things that need to be adjusted. going forward. But there is a lot happening in that space right now. What is the performance standard for a DAA system? What is the means of compliance to get that DAA system, which is no small task, because think about what detect and avoid is trying to do, is trying to prevent that collision. Well, when you go test that collision, what happens if it fails? Civil aviation authorities don't like having aircraft accidents as they go testing out these systems. So we're working around all these different issues and variables trying to get that solved. But industry is critical to our research, and small or large, we bring in others to kind of work with it. But it's a pain in the ass. It takes up a lot of time. It takes up some resources to participate. And then every now and then, what really frustrates some of our industry partners when we work with them, like we've been working a lot of certification things lately on how to certify different size and different types of aircraft. The FAA kind of gets lost on itself and not knowing how it wants to proceed. We at Assure we do have some political push through Congress to beat up on the FAA a little bit. But if they say no and they stall, and then industry ends up stalling with us and the FAA trying to move things forward sometimes. And that can be rather frustrating. They'd like being in that initial group getting through because they can be first to market if they win. But if the FAA, of which they have no control over, says, oh, we're going to slow down here, we're all kind of screwed.
So has your work had any tangible, have you seen any changes to regulation as a result of the work you've done?
Yeah, look at ops over people. All that is really done by the Assure work that was generated. What's happening now is different means of compliance for ops over people. The FAA has been rather slow because when the ops over people rule went into effect, they didn't use the Assure rule. What they did is they published a rule for it that was out 4 years before we even, or 3 years before we even did the study. And then they backed it in with means of compliance because they didn't want to have to go through the whole process again on how to do that. But that's just one example. We're doing a lot of work in certification, what kind of things and materials. And I suspect you're going to see a lot coming out on beyond visual line of sight and detect avoid. Risk ratios, how well. We're doing a study right now looking at the human eyeball, and in different environments, the assumption always was, well, we need these UAS detect and avoid systems to see everything. Well, the eyeball doesn't see 30%, more than about 30 to 50 in the perfect conditions. So really, the detect and avoid really just needs to match that standard, right? So that's being worked on right now.
You must look at the work that the Blades did, which is Group of ex-Air Force pilots in the UK did with the Royal Air Force more than 10 years ago now, where they made a matchbox size, not a cigarette box sized detect and avoid camera system, and they aggressed it, a Seneca, and they aggressed it with some aerobatic aircraft consistently, flying in from many vectors, and they sat the two pilots in the Seneca. They called when they saw the threat, the aircraft coming for them, but the camera system picked up. They had to turn it right down. It was picking up birds lifting from fields miles away, and I was lucky enough to, I don't know how I got into a room with lots and lots of scrambled egg on shoulders and things like that, and the guys just said, look, we should actually fit this to all the jets, all the aircraft. We should all have this. It's not happened.
Well, the problem, no, but it is happening because we're doing right now. We're in a study trying to help out again for UTM and beyond visual line of sight detect avoid systems. You brought up a key thing. You needed to detect and avoid needs to be able to a couple of things. It needs to be able to detect a problem, not have false positives. So all those birds flying around, that's a challenge. Be able to ultimately maneuver so we don't have the impact, right? It just detecting it is not enough. So it's got to detect it soon enough. And then the aircraft and autopilot system has to have the maneuverability to be able to get, out of the way. So all of these things are playing in what you're saying, but this whole track classification problem. Look at the balloons, situation. You put these filters on and they block things. You put a filter on a road that because of the speed of the highway and the road nearby. Well, but then again, that's a nice path for a drone to follow. So do you block the road? How do you do that? Those tracks classification. There's a lot of difficult issues. Now, I would say overall, we're making the airspace much, much safer through these studies, not just for unmanned systems, but for manned aircraft as this stuff moves forward.
But for see and avoid, wouldn't it make more sense just to have ubiquitous conspicuity? Then you don't have the see and avoid problems. Everything is telling you where it is, and you don't have to rely on filters and things. You've got absolutely accurate information from everything that's in the sky. Why not just mandate that all aircraft, manned and unmanned, have to have electronic conspicuity? Problem goes away instantly.
Well, so what is that electronic system? So ADSB in a RAND study years ago, or MITRE study years ago, found out that it would, the system as defined would become saturated if we put these things on all UAS. Remote ID is coming out, but remote ID was never designed. It was supposed to just ID the system, not necessarily provide any spots. So your solution is a valid one. The question is, will we go there or not? And we're doing some look at remote ID to help do that in the electronic conspicuity. That's a word I always struggle with. But also some other thoughts have come out in a low power ADSB type situation where you can filter out that what it's, just in power, if it only goes out, because you're really only concerned about probably about 2 kilometers in with the smalls in particular, not bigger aircraft, but smallers, about 2 kilometers. So now that airliner flying overhead is not seeing you. But then when you put it through the web, it has to somehow be filtered. So it's not a simple solution, but it's a solution that merits more study. That's why we are being given the conspicuity task coming here. The problem was when our researchers saw this and we started asking a bunch of questions that we choked the FAA and okay, there's a lot here. A lot can be done. A lot needs to be considered. How do you want to scope this in time and effort? And do we want to phase it? What's most important to you? And as a matter of fact, I have a call on this in the US at 9 a.m. in the morning, trying to get this thing started, get it moving.
I think we might be able to. I have a hunch that the drone and model aircraft industry actually might be starting to hold manned aviation's feet to the fire of safety, because we're kind of exposing a lot of stuff. And to try and give you an idea of scale, I don't know how well your connection's going, Philip, but sort of a rough ballpark figure, sort of how many autopilots are you selling a month?
Us personally, about 4,000 to 5,000 a month, and we're only a small part of the industry.
Yeah, so the numbers are growing, and well, Philip's got a Harrier, for instance, or part of a Harrier. So we're not all coming from buying stuff from Best Buy. A lot of us have got real aviation experience, and it's time just to, I don't know what I'm saying, I don't know what road I've gone down. It's just time to demand of regulators that they pay attention and that we're not just all kids buying stuff from the dollar store. We are all interested in a safe, equitable sky. We're not.
I think that's.
Go on, mate.
Yeah, that's important, Gary. I mean, my background, I'm an aircraft engineer. I've been in aviation officially since 1994, though, used to fly Cessna 185s around the bush in Africa well before that. But, we used to do avoiding of elephants while flying way too low on the plains in Zambia. But, thankfully we didn't have to think about other objects around, but we did have to watch out for birds and things like that. And you know, hitting a big bird is pretty nasty in a small aircraft. And it's actually the small end of aviation that concerns me more when it comes to drones. I mean, a windscreen on a Cessna is made of acrylic. I mean, why are we still allowing light aircraft windshields and helicopter windshields to be made of just straight acrylic? I mean, a small impact and they shatter. They shatter into shards. You're not allowed to have that sort of thing on a car, because, you know, if you go through the windscreen of a car, or it's got to shatter into little bits of glass so that it doesn't cut, etc., etc. But in general aviation, we still allow these massive blades of acrylic that get shattered when things hit them. That worries me from a drone point of view. And, you know, so yeah, we put ADS-B on, we can avoid problem. Light aircraft, most countries don't fit ADS-B out in the first place. So, you know, we talk about camera systems, we talk about all this detect and avoid and blah, blah, blah. But the full-size aircraft, and by full-size, I mean the small end of the full-size aircraft, don't obey the most logical of common sense engineering improvements that have happened over the last, you know, 30, 40, 50, 70 years. We're still building aircraft as if they were built in the 1940s, 1930s. And yet we've got drone ID now, we've got, you know, registration, we've got fees for all of this stuff. We don't have airports, we don't have all of this stuff that we need, we don't have infrastructure, we have no benefit from all of these fees, and these new rules don't actually stop a drone flying through the windscreen of a helicopter or a Cessna 185 or whatever. But we have an airport incident where someone sees a plastic bag or something, and all of a sudden we're shutting down, you know, airports from airliners that, as you guys have sort of shown and are continuing to show, if they hit a drone, it's expensive, it's embarrassing, it's frustrating, it'll be bad for the industry. I hope it's not our autopilot on board when that finally happens. But the aircraft will do a circuit, it will land, and then the engineers will get really, really annoyed at the amount of work they've got to do. Passengers will get annoyed, but that's where we're at. And for some reason, the public and the regulators are heading down this doom and gloom path on airliners, but not on GA. And it's just, I mean, it's quite depressing. I mean, you know, we get a good old XJet tweet where we've got, you know, holding up general aviation to the standard because there's been another mid-air collision between a Cessna and a whatever, or two gliders or whatever. I mean, this stuff happens all the time with the most professional of pilots on board, and they don't have detect and avoid systems, and it's just sad. So I hope that we can convince regulators, and it's good that the FAA is working with you guys, but CAA UK, I would say, is probably the biggest offender when it comes to not using real data, using fear, and being absolutely paranoid and ignoring your data and preferring data that is set up to fire javelins at unmounted, broken windscreens. Like, how do we get this step from you guys doing real science to CAA just peddling fear? Like,
so
yeah, sorry, I'm rambling now.
Yeah, so let me just throw out a couple of points, and then I'll answer your last part directly. So when UAS, RPAS, whatever the term is around the globe, came into the airspace, they were called the new entrant, the new emergency. And most aviation national airspace authorities, the new entrant is responsible for not increasing the risk to the airspace, and everything revolves around the new entrant. Hence, space flight. We see a lot of that in the United States now. They're having to do all kinds of machinations, although changing, and I'll get to that point here. And then UAS had to do everything. But when I sat in the Beyond Visual Line of Sight Aviation Rulemaking Committee that was held last year in the United States, for the first time I started hearing things, and I'm seeing it now in the research, rules of the road or right-of-way rules. that the FAA is backing off of that. They out of the arc, and even when we ask specific questions in the United States, whose airspace is this? It's the nation's airspace. When ag pilots were saying, this is our airspace, you've got to keep drones out of this airspace. This is our airspace. It was, no, it's not your airspace. Matter of fact, we've given you all kinds of privileges of not equipping that in the future might have to change. And, we spend a lot of money on ashore researching, but we can probably give everybody an ADS-B handheld, and now they'd be much, much safer. So the FAA is beginning to make that twist and turn. The FAA is the one that's also pushing me to work with standards committees, other civil aviation authorities, and governments around the globe to fix this problem. So the direct answer to that is why I was in the UK right before Christmas. I was over just, trying to bring on, again, the way the British government tries to work in aerospace. Everybody loves Cranfield, and Cranfield works well with other universities, and it's a perfect situation. So I met them, and prior to the holidays, I was able to get a vote of my universities to bring them on board. So now, as we work in the future to do some work and pass information across each other, Cranfield can be our direct contact, and then we can work projects through them and things in the United States that will inform them to help out the Civil Aviation Authority. The other thing is, I'm talking less and less to civil aviation authorities and more to like our Transportation and Commerce in Congress and your Ministry of Business and Innovation. In Australia, the same thing. They have the same kind of order, and they get it. They understand that this is bigger than just aviation regulation, which is highly risk adverse to what benefits these things bring. So all of these things are starting. Obviously, it will not go as fast as you want it to because of this whole thing with new entrants, certification. Everything I have found in our research is so much more complex when you start peeling back the onion. These aviation authorities live there, so they're fearful of everything because they're going to walk around the corner and there's going to be another wrecking ball kind of going for their head. So I can appreciate what they're up against. What we need to all do is to help step them through those risks and show them and the public why it is better to do this versus staying on the path that we're currently involved. And that's what has shifted, at least for me in Ashore, is I'm working to how do we get to the public and the benefit of UAS and these smalls and then autonomy in general. How do we get there? One other point is in certifying that acrylic windshield, that class of aircraft and everything associated with that's being built to the same standard that came out in 1945 is because it's so darn onerous and so expensive to do that. We're trying to also, with these new UAS systems that are kind of in the World War I phase of equipment, how quickly it's all changing, to do much, much more into, as much as possible, modeling and simulation certification, and then figuring out what you actually need to flight test, because that's the expensive side of flight test.
I'm going to have to disagree with you there, Steve. I reckon we're about 1930 or 1935. And don't forget, when you said the World War I, the first drone flew in 1917. So the idea that we're a new entrant to the sky, and the word drone comes from the Queen Bee in 1936, I think it was. So the idea we predate most of these aviation authorities. So
we were here first. They're the new tech. They should step aside. Actually, one thing that Steve said, and I think it'd be great, I'd like to see the simulation of a wrecking ball going through a regulator's head. Can you arrange that?
We can probably do. We can probably get you there.
But it's the framing of the thing, isn't it? To say new entrants, it is a little
Yeah.
bit disingenuous. That
well, it was because they're coming in mass. You know, it wasn't
Yeah.
a problem, and they
Sure.
tried to ignore it. They tried to just ignore it until that Christmas. I don't know, 5-6 years ago, where 200,000 drones were being sold at Christmas.
However, let's be blunt. Even that Christmas happening was actually a direct cause of DJI's boom. Was the fact that the Department of Commerce decided that 3D robotics was doing dangerous things by having autopilots available around the world and banned their export, which sort of led to the boom of Chinese autopilots, which made them really cheap, which made them affordable, which boomed the hobby side of things, which boomed the professional side, which gave a market. Like, it's actually regulation that stopped America being the number one in this industry. Like, regulators need to consider that being cautious to the point that you stifle a local industry can have follow-on effects that, let's be blunt, in today's world political climate, China is the world leader in drone aviation. That is now a fact. And the US is desperately trying to regulate their way around catching up. And it's actually really frustrating being that we're an open source community, like just watching this train wreck happening, and yet knowing the results and not being able to do anything about it. That has been very frustrating from the open source community. But yeah, just watching regulators actually do damage to aviation. There's things we've been promoting. I mean, the use of ADS-B. I mean, Avionics as a company has done incredible things for ADS-B as detect and avoid by making their tail beacon and nav beacon that can screw onto the side of a 1940s era beyond aircraft. I mean, the convenient thing about the 1940s is they made very standard navigation lights that nearly every GA aircraft is still using. So you just unscrew one of them, screw that in, and boom, you've got ADS-B out. Our drones can auto detect you with the Avionics ping that's on board, and voila, you have a safer system. And yet they're running around the world trying to convince regulators this is a good idea, and all regulators are saying is, oh, ADS-B has some problems. Yep, we all know ADS-B has some problems, but there isn't any better technology yet that actually works. So let's use that for now until someone does come up with something that is more scalable, blah, blah, blah. Yep, we're not transmitting, so we're not flooding the airwaves, and it works.
The US
it
side's
actually
not
works.
Transmitting.
Yeah.
Yeah.
Now, obviously, now we have to deal with the fact that we don't want UASs crashing into each other when you've got an Amazon Prime versus a Google Wing delivery trying to fight each other's airspace. We obviously don't want them hitting each other, but that's another problem to come. But we actually do have solutions to a lot of these problems. And why does it take 15 studies to prove that there might be a problem when we already know there could be some problems and we can already work on those solutions? And then fair enough, if the problem turns out to be not as big as we thought it was, great. But like, I mean, I feel like on this show we do ramble a lot. We do go over the same stuff over and over again. And the reason being that we do have solutions. We're building hardware, we're building software, we're building solutions. The industry is adopting the solutions. I mean, the only certified UAS that are out there run and when I say certified UAS, I mean commercial, not military, that are actually doing deliveries and stuff, are all running open source Archipilot on Cube autopilots. You know, this isn't stuff that the regulator brought to us. This is stuff we've worked really hard to prove to the regulator that we're safe.
Right.
And we'd love to have better methods for doing that, et cetera, but it just feels often like we're just banging our head against a brick wall saying the same stuff over and over and over.
So my only suggestion there, so Assure, that's why Congress created us, is to help industry work its regulatory risk, right? And that's what I see my primary job is reducing regulatory risk around the globe. Now, to do that, we have to have a great relationship with industry. We got to bring forth with the limited resources, time, money, bodies available to attack issues that are, you know, first, second, third, and fourth. And we do that with our industry in the US primarily. But we're always open to new ideas and how to do that. But that's why industry is, and why we have the one-to-one cost share, is because the expectation of Congress is to do industry. And also our US Congress, we're finding is the one that is poking the bear, the regulatory non-moving dormant bear to wake up and get moving. And they ask Assure constantly to do this. And I'm dealing with all kinds of regulatory language in both the federal and states on how to kind of get commerce going. So we're there's a sea change happening, at least in the US, that there's interest in commerce. There's interest, matter of fact, I've been funded to stand up a whole first training, standards training, education, testing, certification and credentialing of first responders use of UAS. And what's come to me in the last week or so is, hey, can you do blue and green list? Blue list being US only, green list being non-Iran, China, you know, kind of stuff from all our allies. How can you establish that? So we're trying to get some regulatory language in place to establish across at least the US and then UK's expressed interest, Canada's expressed interest, and Australia to be part of this program to start moving out on industry. So the actual legislatures, the people that you're voting for to put in, you know, in your positions of governance are starting to get it. And that, I think, is the biggest change that I see out there.
Have you just given us a bit of a scoop there, Steve? You said green list and a blue list.
That's my terms.
Okay.
Those are my terms.
That actually worries me greatly, to be honest. I mean, as again, our autopilot is 6 out of the 11 on the blue SUAS approved list. We're an Australian company, and yet even though we're on that, we still get companies saying, "Oh no, we need US made." I'm sorry, but there's this thing called AUKUS, there's this thing called ANZUS, there's all of these treaties where we're meant to be all these close allies, and somehow that is mixing into aviation regulation, and
that's not me. That's not for me to fight. That's for you.
I know that, but it does make it difficult because it means that
Phil, let me finish. So what's happening though is, at least in the US, our states and our federal government is ready to dump money into the industry. Quite frankly, the language right now.
But at who? I mean, one of the things we've seen in the past, Defense Innovation Unit would be a great example of money being dumped into the industry. Yeah. And what happens is companies who can afford to spend a lot of time on lobbyists and lawyers get in, and they take something that's meant to be standardized and turn it into something that's into proprietary. An example was the Mavlink as standard comms for UAS that a particular Swiss company got the contract for. So they set up an office in America to pretend they're American. They did the contract, and then all of a sudden they tried to turn it into, unless you're using our system, you don't meet the DIU regulation.
Right.
So
we're being created.
We end up fighting that instead of safety
as another, as an alternative to DIU because of these kind of issues. And the only person that you need to lobby is probably me with an ale as we try to grow this program. The idea, though, is to have different certification centers all across the United States, UK, Australia, Canada, once we get this thing up and running. I don't know what the list color is and who's going to be in. I don't really give a shit. I want want the ability for whoever wants to pay for systems to support public safety, public benefit, and then industry to be able to get that money spent. Right now, everything is, well, it's Chinese, we can't buy it. And then I get stupid ass stuff like you just brought up, but even worse. For example, Mississippi, where I am right now, they put out a rule that we're still trying to get killed before that goes final, that you can only buy Mississippi-built UAS. Guess how many complete parts are built in Mississippi? I mean,
of course. Come
on, guys. You know, this is asinine. Let's manage this a little bit better. But the idea on this thing is I need it to be low cost because, and my focus, what keeps me honest, is I'm focusing on first responders. They do not have budget. They don't have a lot of money. So if I can build a system that has all the procedures in place for their education training, and then when people drop money on them to go buy something, they can go to a list and say, okay, here's the list that I can go buy from. And that enables that sponsor to do it because they know it's been certified in some mean or fashion. Blue, green, yellow, purple, blue, polka dot.
Yeah.
I hate to support DJI here, but let's be blunt. A DJI Mavic Pro with a thermal camera is the exact drone that most firefighting departments need. Exactly. And that's said by someone who is clearly commercially not interested in supporting DJI. But if you just want to go out and buy something that works, you're not dealing with a national security issue while you're trying to fight a house fire or a bushfire or any of those sort of things. So,
we're buying the equipment right now to do some of these trainings and things. And boy, we can surely see the quality step down now because I'm funded primarily through the U.S. federal government. I can't buy a Chinese product, but boy, it's cost more, it's less capable, but that probably will exist everywhere for some period of time. And hopefully our industry will catch up. And when I say ours, I mean the collective ours. Yeah. We gave way too many years to DJI, and then their ability to manufacture at scale just, dwarfs what we can do anywhere else in the world.
Well, it's quite simple. I mean, they've got. Sorry, Gary, go ahead.
After you, mate. No, after you.
Yeah, I mean, DJI have massive government funding. They basically have a mandate to dominate the industry, and they don't need to turn a profit to do that. Profit is not something that matters to them because they will be funded regardless. They're a state actor. That's just how it is. I mean, it's
and they I forgot what I was going to say now, but hats off to them and fair play, really. Patrick and I were on ASTM meetings and other meetings in 2008, 2009, 2010, where people were saying, there's no way you're going to have a sub $1,000 drone. It's never going to happen. Never going to happen. We're saying, yeah, you are. And then he said it was probably going to be sub 500. No way. It's never going to happen. And here we are now, So it was a very blinkered, not made here. And the UK everywhere is guilty of having a very nationalistic sort of, we make the best of whatever it is. And, and no one's.
Yes, we have a Kiwi drone, but it's flightless.
Flightless. There you go. Well, back to the windscreen thing. Of course, the windscreen thing in light aircraft in New Zealand, there was that famous thing where I think was he a TV presenter or a journalist?
Robert Guy Vaughan.
Yeah.
There's a question
to have been hit.
There's a question in chat about U.S. drones and different agencies can a subcontractor use. And right now, we just had a ruling out of the FAA, and probably others are probably going to be the same way. If it's subcontracted, it's by extension not approved. Now, Shure has worked with Congress and the White House to try to get carve-outs in any of these final language for R&D. We need it for counter UAS. We need it for 80% of what's flying around in the airspace. And everybody's been generally supportive of that. But for what we see happening in the future, happening now and getting worse in the future, is the shutdown of supply lines and right now it's anti-Chinese drones. And what our poor first responders are saying is, well, that's all I got. You tell me I can't fly these things anymore, at least let me phase them out over time. So there's just things like that there's so many problems. I wish I could work them all in a day, but I can't. And, we're tackling them bit by bit. There's no perfect solutions. And when I tell my team is we're looking for that 70, and I use this in the Air Force when I was doing innovation within the Air Force, 70% solution is good enough. And I don't know all the problems we're going to face, but we'll start tackling the biggest ones first when we get to 70% and start implementing, and let's get going. So that's kind of how Assure functions right now. It creates a lot of turmoil within the group as we do things, but we think we're moving the ball forward somewhat. Although I'll need to be replaced by somebody who's an I and T crossing kind of person to get everything much more organized when it's time for me to retire.
It's amazing stuff. I know other Ian, who's not with us because he has COVID, so he's not feeling very well, asked me to ask you, and it sounds like you are working with the CAA and DFT in the UK, but have they funded studies from you?
No,
No,
unfortunately not. And we've only had a few talks with them on what they're doing. We haven't connected, but at the discussion with the business innovation folks and others in the UK, I decided to go out to Cranfield and see what they got going. And it's a great place. They're doing great work. And, when I have a few moments, I hopefully will sit down with them and we can work out who to attack in the government to actually sponsor programs. For example, if you guys have an issue and you know of some way to sponsor, what I would like to do is the way I would manage that is I put our lead, PI from the US is in consultation with Cranfield and then the subordinate universities. So the British pounds are spent in the UK, not in the US, so as little as possible. Same thing with Australia, New Zealand. We're creating the consortia there to do that. And what's most important to you guys or the UK needs to be solved in the UK. And if it's not prioritized in the US, so what? And then we'll steal those findings and that research, share what we're doing, and we just keep moving along a lot faster.
I assume you've seen the study that was it Kinetic did with the impact to airliners, where they were shooting, javelins basically at windscreens. I'm assuming you've seen that.
Yeah, they sent it to me, and basically I looked at it for about a moment or two and could tell it wasn't to the quality that was demanded of our work.
Yeah, because the problem is studies like that are used, and since Gatwick, that study's been used multiple times in Australia with the regulator, and Gatwick keeps being used as an example in regulator documents, where we still don't actually have evidence that it actually happened. Whereas what I'm not seeing is them using your data. We all know your data exists, but trying to convince the regulators in Australia to actually go, well, hang on, there's some real data here, let's use that. When they seem to love the little bites where you've got this image of a javelin going through and damaging a windshield, and the fact that was done well and truly outside of the original test parameters in the first place is irrelevant, because the news gives it 15 minutes at that, 5 minutes, 3 seconds, and everyone goes, ooh, drones, and that's it, game over.
That's all you have to. If you've got a story to tell, that's all you've got to create is enough of a. You've got to get a person with a clipboard and a white jacket on to say, this, and this one washes it like this, and this detergent works like this, and that's all you need, because you've got to get it into the press, and that's your aim. Your aim isn't for science. Sorry.
Yeah, what we did, and this was actually as Assure was stood up, so I can't take credit for it, but I use them every day. We have a public relation firm that has great relationships with a lot of industry, the papers, the news, the media, And we have commissioned them and pay them every month, regardless if we need them or not. And the FAA floats that money through to them once they saw how good of a job they did on explaining our research, the good, bad, and ugly of it, but making it make sense, not being used just for sensationalism. And that happened. I mean, I was on the job maybe not even a month, when there was a YouTube video of drones, being used by terrorists, blowing up engines and flying through fuselages, and that became all over the place. And my first duty was to respond to that. And fortunately, we had that PR group. So that's something to consider in any kind of association, is to formulate, even as a volunteer group, that can pull forward these other kinds of studies. We have some pretty videos and cool looking graphics and stuff too. But to pull that stuff forward so that the public starts seeing more than just the fear mongers out there. Now it's shifting a lot in the U.S. because of the utility side of it is starting to be seen, saving little lost doggies and grandpa who's got dementia out in the woods. Those things are starting to help turn the tide.
Absolutely. Now, what's floated into my head now is balloons floating over America. No, that's another subject. So let's say we're a model aircraft association, a community-based organization. Oh, a new one stood up in America. There's a new CBO in America. But anyway, that's another story as well. Would you liaise with the BMFA, AMA, and all that, and say, we operate like this because we are operating to the Assure standard this, and Assure says model aircraft associations, if you fly in this manner, this is how safe I'm thinking this aloud. This is how safe we think it is. So we start as the modeling community side of things, letting regulators know that we've heard of you, we trust your data, and C, we're using it in the way we operate. Sorry, that's a made-up thought. That's just come into my head. After you.
I think that's a valid question. I like that.
That's what we're doing for the first responders. That's obviously very operationally focused, but there is some basic skill sets. Now, we're not going to give them their basic pilot license training. We're gonna leave. There's tons of that out there. But how do you best employ UAS in a city fire, getting airspace protected? How do you do it in backfires and wildfires and coordinating with the water bombers and all of that? Or if you're an emergency manager who's managing a huge fire, how do you set up the airspace? All of that is what we're doing in that first responder program. Could we potentially shift, or another organization set up some level? Okay, CA, what is your concerns with the modelers? And what kind of certification or training would alleviate that for you? We could potentially do that. We have been asked by other countries to come in and establish test ranges, do the initial cadre of that and the courses that would be required. And we usually tie it to some national need or local need, like bad water, flooding, so that they can actually build their own sensors and get a win out of it. It takes us maybe 30 to 60 days to get all that up and operating, and then we leave. We're done. That now is an inherent capability of that country or that state inside of a country to go do. And we're still there if they need any consulting back to them. But our intent at Assure is not, we're a nonprofit, so we're not trying to make any money. I'm just trying to get these things into the airspace where it's safe and do it safely and efficiently across the globe. Whatever those issues are, we're happy to tackle within the resources that we have available. But that's exactly what we're doing for the first responders, and to help them get funded with systems and knowledge that's not, just out of fear or just innuendo kind of.
Yeah, exactly. So we, as a model aircraft flyer, I mitigate the risk by doing this, which they have done for hundreds of years. And the trouble is, we're trying to justify a thing that isn't a problem. or I'm trying to justify a thing that isn't a problem, which is a shame. But at least if the regulators realised that we weren't just making it up and we had other
I'm just making
data
it
to
up.
back it up.
Well, and if you become part of the solution too, the regulators, especially the civil aviation authorities, really have no law enforcement body or people.
Well, no, that's what RID's for.
Right.
They've generated it.
So, modelers who are out there and tail watchers who are out there looking, recording aircraft with some level of some specific kind of training could be very useful to civil aviation authorities and regulators to keep the airspace safe so that you show that you're reliable. Now, you're a little bit of a tattletale, maybe, but maybe you can also walk up to that guy who's getting ready to launch the drone so he can watch airplanes come in and land while he's up in the air, and you go, no, you're not going to do that. Pack it up, leave. This is why you're not going to do it.
Yeah, I've said that for a long time. We are the best enforcement army out there because we know exactly what is safe, what's not. We've got our feet on the ground. We're likely to be there when other people want to do stupid things. And I believe that the regulators should be building stronger links with this community, especially the traditional hobby, because remember, we have been, as Gary says, doing this for decades. Yeah, recreational multi-rotor drones are a new thing, but it really concerns me that regulators are clearly aware there's totally different risk profiles, totally different applications, totally different craft, yet they apply exactly the same rule sets to both, and that makes no sense at all. So do you wonder yourself, Steve, if there's something driving this beyond simply the safety thing?
So out of the arc, that changed. So the different levels of safety were acknowledged, at least by the FAA, for different types of operations. And some of our research has looked at this, that de minimis risk. If I have and this will come with our conspicuity, if I have a special drone that is the one that's run into accidents to give the coagulant for the people that are on blood thinners, or the hospital drone that's racing a heart to some other hospital, there's some things that we probably need to do to that drone so everybody knows it's an ambulatory type drone, that's an emergency drone moving, but it only needs to be this safe. It doesn't need to be everything else. It's the same thing we do with ambulances. We put noise things on them. They can go through lights. They can do all that kind of stuff. They are actually less safe. Now they build up that safety because they make everybody else responsible with that conspicuity, the noise, the lights, and everything else to get the hell out of the way. And I think the FAA has acknowledged that recently. And I'm not sure how this is going to actually play out in regulation, but they now recognize that there's different applications, different things that have like shielding, like next to a tower. There's no aircraft getting next to that tower. So we really don't need this huge level of safety for that aircraft. We don't. And railroad inspections, doing the rail lines and the power lines, those are easements. There's nothing underneath it other than maybe a rabbit or a squirrel chasing down the rabbit and looking for a good time. But those kind of things are now starting to be acknowledged, and we need the big gorilla like the FAA and EASA to start articulating that more. But it's just starting, and it came out of that arc, and some of the things that I was hearing from them that I had never heard before, and then some of our latest research that they're looking to do. Now there's concerns that people will cheat and try to take advantage of some of these lesser loopholes of different areas. But we'll like I tell them, let's address those as the one-offs and put them in jail for a year, or fine them so much money that it kills them.
Shoot them all. Let God take care of it.
Yeah, exactly. Yeah. But
yeah,
I see that.
I think that one actually nails. Like enforcing existing regulation is obviously an important point in reducing unnecessary regulation. I mean, we keep getting this new thing like, drone registration will improve safety. Well, I'm not sure that there's any data that actually has come out of there that says that we've lowered the fatality rate from drones, because it really is hard to lower it from 0 to, I don't know, bringing people back from the dead. Like drone ID is the next one. Like adding drone ID, I can see where the logic of the benefits is coming from. However, what concerns me with drone ID is a local reporter goes somewhere and is filming something that is bad that's happening, he might be an investigative journalist filming someone breaching EPA regulations. They're broadcasting not only their drone's location, they're broadcasting their own location. So-and-so comes over, boom, there goes the thing. You've just increased the deaths due to drones because the drone pilot got shot by the mob boss that he was investigating. Like, this is the consequence of adding safety in where the safety case isn't proven. Now, I perfectly understand remote ID being enforced when you've got the Super Bowl on. If there's, appropriate TV organizations that are flying drones around the Super Bowl, that they're broadcasting, hey, I'm a friend, I'm a friend, I'm a friend. Any drone that isn't broadcasting, well, shoot it down, whatever, cool. I'm good with that. But, Bruce down at the park doing a little bit of FPV stuff, not that Bruce would ever do that, but why does it matter? He doesn't need to transmit his location because the local police know who Bruce is well and truly. There's, like you say, there's categories of risk, and flying a drone over the Super Bowl, what is that person's intention is significantly a concern. Whereas flying down at the local park, what is that person's concern? Well, and their intention, less of a concern. So yeah, being able to categorize stuff, and you mentioned medical deliveries. Obviously, Mission Go has got the FAA certification for their chopper, which is awesome. Obviously awesome for multiple reasons, but it is important that we start getting that segregation. It's really good to hear that the FAA is thinking about that.
Yeah, and especially when you get into issues of kind of the counter UAS, understanding what's in the airspace. That very much I see. I'm a fighter guy from my Air Force career, so you need to tier the levels of risk and vulnerability and all of that, threat, vulnerability, and risk to different tiers, because as a fighter guy, I now need to know what a hostile intent, hostile action is. Do I wait for stuff? What, how much do I employ against him? Or if I really don't care, I'm just out enjoying flying up and down the beach, looking at the sunbathers on the beach. And I'm just, there in case somebody comes flying in that's an unknown rider into the United States. So all of that will change. And there are, in the discussions of, how intrusive we're going to be is related to this tiering system. Again, really early in the research, but that I suspect will be it. Because in the United States also, we have things called Title 18 wiretap, pen trap law that we're not allowed to listen in on these frequencies. We're not allowed to store the data. But as the risk level increases, then maybe you can listen and identify a drone. You just can't store it. Now you can identify where it is, go figure out what it is. But then if it's a Super Bowl event and there's been some threats against it, maybe that's the highest level. And now you're listening and you can actually jump on that frequency and land the aircraft immediately, things like that. So these kind of thoughts are now, and I would say keep staying vocal, are starting to play into the solutions.
Now, Steve, would it be fair to say that, as we mentioned earlier, you mentioned that the overall risk of aviation activities is reduced by using unmanned craft because you're reducing the number of high-risk operations, replacing them with low-risk ones? So would it be fair to say that given the amount of latency, the lag involved in having regulations that are fit for purpose, there's all this ultra-conservatism, ultra-risk aversion with the new stuff, is the slow pace of regulation actually one of the major impediments to aviation safety these days?
So in specific to aviation safety, I would say it depends. It depends on how we come through with the rules and laws. I would say overall safety, systemically, I cannot see how use of robotics, autonomous systems, drones cannot but help systemically across the whole of transportation, infrastructure inspections, bridge inspections, all these things that are dirty, dangerous, or dull. that get human beings hurt and killed, that there is not a benefit to doing that. We have to work at the whole of government to come up with solutions that will allow the transference of risk from one agency to another. It needs to be acknowledged, because if I'm doing something in aviation that now makes something a little more dangerous on ground transportation, they need to know about that so that they can, if they need to mitigate, they can figure out ways to mitigate. But then there needs to be some higher power of government to actually make those rulings. So CAA acts independently on all air because that's all it's got. And somebody else works something else. We do need some super kind of structure over in the whole of government to balance in the executive branch of our service to balance out those kind of risks. After a while, they'll figure out, yeah, this is stupid. I increase risk 10 to the minus 12, but I'm saving lives every single day, 5 to 10 lives here by doing this. Or, we crash on our power line inspections. We have 10 crashes a year where we injure about 50 people a year. And we have over a decade, about 50 people killed doing power line inspections. And there's no reason that we don't just do it with autonomous systems and UAS flying up and down these things. They get a little too close to the wire, or they back off and catch a tree branch nearby, and they're in the ground. And it's now the pilot's skill to be able to get that thing somehow safely to the ground and preserving life.
I think power line inspection is a great example. I know in Australia there's been too many people die in power line inspection. I mean, you stir up dust, you lose orientation in the dust storm. There's so many applications there where an autonomous vehicle doesn't care.
Sure.
Now, does that mean that we're not going to lose? We're not going to lose autonomous vehicles? No, we will lose autonomous vehicles, and that's okay. And I think it's and that's okay bit that the regulator also needs to recognise is drones are disposable. I saw a crash report done by someone because a mining company was using a UAS to film an explosion face, and a bit of shrapnel hit the drone, destroyed it, and they had to do an investigation on the crash. Well, it's just a cheap GoPro that's been put in a convenient position for a thing. You don't have to investigate that sort of crash. It was expected. It was planned. We knew it was going to crash, and who cares? It doesn't matter.
And the trouble is that goes in the data of crash, and that almost swings when Diane. If you rewind, just to answer Diane in the comments, when we finished, which we're really keeping Lux here a long time, but this is such a fascinating conversation. If you rewind, we spoke about engines, and Lux is going to do a test with a jet engine and chucking a drone in it, and we spoke about that at length back at the beginning. So please rewind, and came up with some incredible arguments with that. Now, where did I want to go with that? Oh, yeah. So the AAIB in the UK has a thing where if you report an accident, then it's not to finger point. They want people to report incidents and accidents to improve safety for everybody down the line. But unfortunately, they've taken, now the CAA, so it's two different things, the CAA are taking just some of that in. So what Phil's just mentioned, Australia would have gone down as a drone incident, and that'll be a count of 1 of drone incidents, and they're counting up all these little things that really shouldn't be drone incidents, because as Phil's quite correctly said, we could expect to lose them. It's not the same as an aircraft. Now the AAIB and the CAA need to come under some sort of censure for a fairly young PPL. I think it was a tail dragging 172, something like that. He ran it through the fence at the end of a small runway, and he never reported the incident or accident. And then they just pushed it into a hangar and hid this whole thing. And then eventually the AAB got to hear about it, and they haven't enforced. So we're coming back to the enforcement thing. They haven't actually. They just said, "Oh, sorry, son, no, it's terrible. You crashed your airplane into a hedge. Oh, well, never mind, but just don't do it again." There was no real enforcement on that side of things. If somebody, and I can see the AIB investigating an M300 crashing in a hedge, stopping in a hedge or a tree for whatever reason. And I can see there being a huge, full and serious report on that, and what a terrible risk and danger it is to the world. Oh, sorry,
Well,
I'm going to rant. But
so if I can jump
is
in,
important.
just real quick, because we had this happen in the U.S. So a couple points. Let me hit the example first. So Hurricane Ian hit Florida hard, right? But for the first time, Florida Power and Light had a whole series of UAVs situated to fly up and down the power lines. And these are dangerous areas. I mean, there's all kinds of swamp creatures and things that you don't want to run across, plus live wires in the water and everything else. During that event, the FPL throws out the fleet. They're doing their thing. But one small UAS ends up hitting a power line and actually taking down the power for about 250 residents. This makes one news cycle, because throughout the whole thing, all these other drones doing their thing up and down power lines, they are actually able to repair things so much quicker in the millions that this news cycle just dropped. Now, should they investigate what happened? I'm okay with that. Go figure out. We're a new industry. And I know we can argue that, but new things developing and new ways of operating. Let's go look at what happened. But the answer overall was this was a huge win. We're not trying to shut it down. We're trying to benefit from maybe there's a lesson learned here. And I suspect what it was gusty winds, that they were just kind of a little too early on the smalls, trying to capture, some of the couplers and things that they were doing there. But the bottom line is it was a win, and the whole narrative flopped because FPL is like, this saved the day. Our guys weren't at risk. We didn't lose any lives. We knew exactly what we needed. We went out to these sites with boats because we knew that they were flooded. All of that because of the reconnaissance capability of the drone to get up while things were still a little icky was beneficial for all Florida residents.
You're right. The enforcement piece. None of us want to be the drone police. None of us really want to have to report stuff and do so. Oh, you do. You do. Okay. All right. You do.
As long as it pays well. Yeah.
As long as it pays. Yeah.
Gary, it's worth answering that question that was asked a little while ago. If a goose can take down, the flight in the Hudson, could a drone do the same thing? The point to mention on that one was they flew through a flock of Canadian geese. It wasn't a goose. It wasn't, it wasn't even two geese. I mean, two geese perfectly aligned with the engines may not have even brought that thing down. They went through a flock of geese. They got absolutely pummeled. The whole aircraft was pummeled by geese. And the aircraft was perfectly flyable, other than the fact of it was unable to maintain altitude. It was perfectly able to maintain attitude. Yes, they did an incredible job. He made some incredible decisions, and he got everyone home safely. And at the end of the day, that's what aviation is about. It's getting people home safely. It's not about getting you to your destination. It's about getting you safe back to the ground. And unfortunately, we do tend to get this narrative of, that was a disaster. It wasn't. It was frustrating for everyone on board, terrifying for the pilots, terrifying for the people, but they all survived. And that was a massive flock of Canadian geese. And those things, I've been up there in New York and seen those geese. They're huge things. And a point to mention on compressibility of water at speed. Water, when you're going more than 70 miles an hour or 70 kilometers an hour, I think it is, it's not like concrete. It does move, but it has a fair bit of inertia behind it at that sort of speed. So, up to 9 kilos or 9 pound, I can't remember, but they're pretty heavy birds. You hit something like that, you're going to do damage. You hit one drone, well, it's a fraction of the potential damage. Now, fair enough, if you're doing a drone light show and an airliner flies right through the middle of a drone light show, you've got some air traffic control problems as well. But also drone light show drones tend to be really, really tiny. because they're expensive to build big ones. So,
and they're all lit up. You can see them.
Actually,
that incident was actually a triumph of safety engineering and systems design. I think the fact that everyone sort of walked or swam away from that shows just how well the safety systems are worked out and how effective they are.
Yeah,
it needed the man in the loop to make the right decision, which was to go for the river and not to try and be a hero, turn back, etc., etc., etc. There was an awful lot of. So that was
Tom Hanks did an amazing job, didn't he? He just worked out how.
Who knew he could fly a plane?
I know, it was incredible.
No.
Tom Cruise could have done better.
Oh, Tom Cruise, yeah, Tom Hanks, he's our man. But it's almost like I'd like Ashore to vet the work of the AIIB, Air Accident Investigation Board in England. There's been some really, really shabby incident reports out of them for drone incidents that show little to no understanding of what was going on. Particularly, I mean, I don't know if you saw, Steve, the airspeeder thing that flew away at Goodwood, and it never. So there was a failure there on the part of the Civil Aviation Authority because they gave it was an Australian manned air racing thing. They should never have let it fly. We did a show years ago when it happened, and I had all the stuff to build one of those on my desk, and that is frightening. If in my junk box I've got the electronics that they use, that just shouldn't happen. So they didn't investigate that. Sorry. I didn't hear that. So they didn't investigate that particularly well. And I say their report so that was the CAA part of it, and then the AIB report of it was a bit like, well, what? They showed us the pictures, and it's like, what? You're saying, what about all this? Most RC hobbyists would not have flown it. They wouldn't have flown it. And guess what? It flew away. So we need a service to hold.
Scary about that one.
So go on, mate.
Sorry, what's particularly scary about that one is that organisation has had world media. They've great publicity, blah, 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 blah. Now, I talked to the head of that company, and he claims he has a completely new crew. They've clean-sheeted everything. They're doing everything again, blah, blah, blah. From what I understand, they're using our autopilot in it now rather than some other thing. But, you know, we've kept arm's distance away from the project, mainly because it wasn't investigated properly. And therefore, I don't have the confidence in saying, hey, that's sort of cool, because I'm not confident of the attitudes within their organization. So, you know, it's not like people in this chat sit there saying we don't want to have the regulator. We actually do want the regulator. We do want the rules. We want the rules that exist to be enforced correctly so that we do actually learn from incidences and move forward. We don't want reporting to be something that's scary. We want reporting. I mean, in full-size aviation, you know, I used to joke that you're a Qantas 747 pilot. You do a loop-de-loop, and as long as you report yourself before anyone else does, you might get fired, but you're not going to lose your license. And that was the whole thing with aviation regulation. And the self-reporting had very little personal consequence, so that people would be encouraged to actually report every single little incident. So we use it as a learning tool, not to ban an industry, not to fire people, not to discipline, but to actually learn. Now, obviously, that's an extreme example. If you're doing a loop-to-loop in a 747, you probably deserve to lose your license. But the idea is to make it really easy for people to report, et cetera, et cetera. But when we introduce drones, you've got to change that up a little bit, because a learning experience of your first drone is going to be crash after crash after crash, and that's okay. It's when we start using drones commercially and we have incidences that could have been a safety thing that we do need to report them. We do need to learn from that. That's why we do service bulletins or safety bulletins with our stuff. And really happy to see Free Fly doing their safety bulletin just recently when they had an incident. We need to encourage more of that from the industry, but we also need to make sure that the regulator has got our back when we do things like that as well, so that it's seen as a positive.
One interesting thing that we have in the US that's been set up is a reporting system that goes to, well, a couple of reporting systems. One on just things like off of engines and, you know, exceedances and problems like that. So now you can capture mean times between failure. None of that data goes directly to the FAA. And then also in incident reports, none of that goes directly to the FAA. It goes to a third party that then works to inform the FAA of potential issues and problems and successes and changes of policies and things like that. I was surprised. I thought that existed everywhere because I grew up in U.S. aviation and I've always known that to be, but I found that it wasn't everywhere. And it's a system that works really, really well to isolate the individual who's trying to get across something that was dangerous or not safe and get it out in the system. And then meantime, like a blade failure or, you know, how long that motor has been flying before failures. Now we can start having time phase replacements of motors. And as a whole industry, we can be much, much safer through these kind of things.
They have a thing like that in the UK. It's called CHIRP, Confidential Human Incident Reporting System. But I promise it wasn't me, but I know of a friend of mine, a good friend of mine, and it wasn't me, honestly, it wasn't me, reported something in CHIRPs, and the next thing he found himself in court. The CIA actually lifted what was supposed to be a confidential thing and used it against him. And it was just like, it got foggy beneath him. It was flying, it got foggy beneath him. He hung around until it wasn't foggy, and then he landed, so all was good. But he wanted to put it out there as a learning experience. This happened to me. This is what I did. And they say he ended up in court for that. So, yeah, as aviation professionals, I think we have to be a little bit careful of sometimes. And that's exactly what the AIB are doing in league with the CAA. They are using data in a dodgy way, you know, again, a bit like the sensationalist media report to make your numbers look good in your reports. Well, we better drag in all those little drone incidents that really were nothing, but somebody's reported it. My batteries failed, my whatever, stuff like that, you know, or a propeller blade rotor failed in a hexacopter, but I landed safely. But that still goes down as an incident.
We have the same thing here. In New Zealand, anyone can make an anonymous complaint or report an anonymous incident regarding a drone. And so there are hundreds of them every year. And I managed to get a list of what the reports were. Some of them were, I saw a drone, or my drone landed in the paddock away from where I was flying, or, you know, things that are no way a safety thing. They're just an occurrence, not an incident, but an occurrence. But they're all labeled as an incident. And so, oh, look at all these incidents relating to drones, and it's very, very bad press. Now, talking to Steve, isn't NASA doing something with RPAS in respect to this reporting?
Yes, they are. So they have their own reporting safety system. What's nice about it is when you put in that report, NASA gives you a ticket. This ticket, and then everything is removed with identifying features and everything else. But you get this get out of jail free card because you report it. So then if the FAA comes around and gets it, you've already self-reported, and you're, even though it might even be totally, they found out a totally different way, it serves to at least greatly mitigate anything that is going to happen to you because you have done this reporting. It's a great program. Hey guys, I just want to point out I have another call at the top of the hour. So.
I was just going to say we're just coming up to. I was just I'm glad you said that, because it was an hour 52. We're meant to go for an hour. This has been just amazing. It really has been amazing, and we certainly have got to work away for the model aircraft community to get a louder voice with you, because I don't know if were you an aero modeler before you were a fighter pilot, or were you just, did you make model airplanes when you were young?
Yeah, I sure did. I had them all over. World War II aircraft was my thing. I had them hanging all over, and then I had my little hook on a string thing.
Yeah, you control. Yeah, so that's under huge threat all around the world. Model aircraft flying is under huge threat, and that's where the next fighter pilots are coming from. Well, no, actually, we don't need them because they're going to go autonomous. But anyway, that's
working.
where our the great engineers that are going to make the autonomous fighter aircraft, that's where they're going to come from. But you know, it's a great hobby. So that needs protecting. And then at a smaller scale, mom and pop drone operations, 1 or 2 person drone operations need protection from regulation and overreach. So those communities need to also talk to you guys somehow. So it needs to be worked up. And as I say, we could say we're operating because Assure says it's like this, so we're doing it like this. That would be a great thing for both those communities. But I think, but I want to, before we thank you finally, we must go to Ian, and he must explain what he is doing there. What are you doing, Ian? We've had endless comments. What are you breaking?
I'm not breaking anything. Can you hear me, by the way? I'm not on the normal mic.
Yeah, we can hear you.
Unfortunately, we can, yeah.
You can hear me.
Yeah.
And the irony of Mr. Rose, who's here, but I'm just finishing a build of one of, I won't say his frame because that's not the right term, is it, Philip? But it is Hex's frame with your gear all over it. Yep. So, yeah, I've just been finishing the 650 is what I've been doing.
Nice.
I
actually haven't seen that 650 personally yet. So
it's big. It's big.
650.
It's very much a 450 bigger. Do you know what I mean? Really, there was a few other little changes to it, but now we've got a nice new Cube Orange Plus on the top there, which is available from the man to my left, stroke right, depending on which way you're looking. The Hero 3 Plus as well. So yeah, it's ready to rock and roll. Basically, once I figure out why my receiver isn't working. Yeah. Does S-Bus port provide power for that?
The S-Bus in the RC channel. Yeah, it does.
I might have been that receiver.
We better let Steve go. He's looking anxious. Gary's gone to sleep.
I've been finishing this build, so this will be in the air and on the channel in the next few weeks.
It looks like Gary's lost his cell phone.
It does look like
he's probably gone. Yeah, he's gone. I'm the boss now. All right, everyone, shut up and bugger off.
So, what can you tell us about something? Is there? This is a nice shade of orange, Philip, like your T-shirt. But I like red. Red is something I really
doesn't show the blood. Steve, you can bow out anytime you like now, mate. You don't have to hang around for these people.
So, yes, at the end of the show, we tend to ramble and rave. Eventually someone just pushes the off-air button and we just continue then for another half hour of rambling.
No, I just wanted to thank you for the opportunity to chat with you guys. It was very interesting. And then all the participants and the comments in the chat, thank you for taking the time and coming today.
It was really interesting. I believe I was listening. Don't you worry.
Best guest we've had for a long time.
At the same time.
Yeah, thank you very much. It was awesome to be able to chat with you, and it's been good watching your work with all of the anti-drone stuff that's going around. You guys are a bit of a breath of fresh air because most people that are associated with government in any way, shape, or form are not quite as calm, cool, and collected as you guys are. So we really do appreciate that.
Thank you. Thanks, guys. Cheers.
Okay.
Take it easy. Look after yourself. Yeah, so red, Philip. Red is a nice color.
Yes.
Is there anything to discuss about anything that might be red at all?
Yes. Well, there is one red in the wild already. Tom Pittenger at Kraus Amani Aerospace has a red, so there is one in the wild. We will be officially releasing it next week at the Australian International Air Show. So if anyone in Australia is watching this, come to the air show, come have a look. We've got some cool stuff at the booth. We're bringing a tracked robot to do a bit of marketing and propaganda for us. They let us drive
Dynamics.
The robot. So yeah, no, we're not a leg. Not a leg one. It's a bit of a cross between number 5 Wally and it lost its arms. But anyway, just a bit of fun that we put together.
What color is the microcube for sub 250?
The microcube is coming. It's white with little gold dots on it, basically at the in its native form, because it's a ceramic material that it's made out of, and it'll be very, 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 very tiny.
Well, good news.
Yes, that is coming. So yes, but by is coming, we announced the Here Pro was officially being released, I believe, in 2019.
I think it was 19, yeah.
Yeah.
Are you a friend of Elon Musk?
Yeah, basically. I operate definitely on Elon Musk promised time. And I made some money out of that last year. I know Robert Lefebvre and Chris Jackson, I think it was, made a bet that the semi wouldn't be released, and I said I reckon 2 years, and I won the bet by about a week from when the bet was placed. So yeah, Elon Musk time definitely with us. Sorry about that, everyone, but it is what it is. So we like to make sure by the time we release a product it actually works. After doing the whole 3DR solo thing and releasing things too early, I may have overcompensated.
Yeah, I think you've gone the other way now. And there's still gold cubes appearing in the wild. I saw another one a couple of days ago.
We've gone to a golden ticket thing instead of just randomly you ordered an orange and you got a gold. Because the problem was people were getting their golds and they actually ordered their autopilot because they needed an autopilot. And people want to sort of keep them, so now we've changed it to they get a golden ticket and they get to keep their orange and get a gold. So, nice. But I believe there's only 20 going out in this batch, so they are very rare now.
Yeah. And so, do we get a tour of the chocolate factory as well?
Look, if anyone wants a tour of the chocolate factory, it's always open. So,
that's it, is it? Have we done it all?
I think so.
Excellent.
Looks like he's not coming back, is it?
No, I think he's out for the count. And it's been 2 hours and a minute, so we might as well finish the broadcast. I've never done this bit before, so it'll be interesting to see what happens. So thank you everyone for watching.
Your first live stream, Bruce?
Well, on this system for Gary, yeah.
Have you done lives on yours? I can't remember.
Yeah, I've done a few. I'm doing my 70th birthday live stream very soon when I talk about the future of the hobby and the cunning ideas I've come up with to push back against regulations. So don't miss that one.
So you're just doing it for the super chats, aren't you?
Yeah, that's it. Yeah. Actually, admission by super chat only. Okay, well, I'll press the button and see what happens. Oh, and there's another button. So bye to all.
There you go.